Here we are in section 1.5 with answers 31 through 42. Find the missing variable. Note if you don't use the pi button on your calculator, specifically for a cone, for a sphere, stuff like that, your answer will differ slightly than what's in the book. And that's all right, but note that your calculator does have a button that has the number pi in it. All right, so we're going to look at all of the formulas for shapes that we have and the different formulas down here as well. So you should have your book open so you can find them. For a triangle, the formula that has A, B, and H in it, area equals 1/2 base times height. And we stick 4 in for base and 7 in for height, and we get 1/2 times 4 times 7. 1/2 times 4 is 2, times 7 is 14, and notice that we're in inches, so the area will be in inches squared. Good. Number 32. For a cone, we need one that has surface area, radius, and then this L. I think it's a little script L in the formula. So it is, let's write it out, surface area is pi RL plus pi R squared. Let's put in everything we have. The SA is going to equal pi times 3.8 times 5.1 plus pi times 3.8 squared. 3.8 squared. Oh, let's plug that in the calculator. That's going to be pretty tough. So the surface area is going to be, there's our pi button right there, pi times 3.8 times 5.1 plus pi times 3.8. There's my little squared button, or you could do a caret 2. And it should equal 106.25. 106.25. And notice that the units, this is an area, so it's measured in meters squared. Square meters, not meters. Area is a two-dimensional object. All right, number 33. For a sphere, look up the formula for the volume of a sphere, and you get volume equals 4/3 pi r cubed. So in this case, it's going to be 4/3 times pi times 16 to the third power. Punch that in our calculators. 4 divided by 3 times pi times 16 to the third power. So that little caret, it does an exponent button for us. And we get 17,157.3. 17,157.3, and that will be in centimeters, but now it's a volume, which is a three-dimensional object, so we measure it in cubic centimeters. Good. Number 34. I have a rectangular sandbox, and notice what we're looking for eventually is the perimeter. So we're going to be doing perimeter is 2L plus 2W. All right, so let's see what we can find. It says the length is 4 more than the width, 4 plus W. And it says the width is 12. So good, that's good. That gives us that width is 12. But length is now going to be 4 plus. If you stick the 12 right in there, we get 12. So the length is 16. Now we can stick everything in here. The perimeter is 2 lengths, 2 16ths, plus 2 widths, which are 12, and that's going to equal 2 times 16 is 32, 2 times 12 is 24, 32 plus 24 is 56, and we are in, what's our unit here? Feet. There it is, feet, 56 feet. Great, number 35. What is the volume of a cylinder? So that's going to be, look up that formula, volume equals pi r squared h. Okay, and it says the height is 3 centimeters less than. Now remember, less than is subtract, but it's taking the 3 and subtracting it from whatever it is, twice the radius. So 2 radius minus 3. Translate that. The radius is 4 centimeters. So good, R is 4 centimeters. So if we take this and stick it in right here, we get the height is 2 times 4 minus 3. That's 8 minus 3, so the height is 5 centimeters. So now we can stick the h and the r into this thing. So that's going to be pi times r squared times h, which is 5. So that is, let's pull out the handy dandy calculator, pi times 4 squared, that's a 16, times 5, so that's like 80 pi, so we should be like 251.3. All right, so volume is going to be 251.3, and this is going to be, now we're in volume, so the unit, we have centimeters, centimeters for length, so this is going to be centimeters cubed. Again, volume, notice that it's cubic centimeters that we're dealing with here. Good deal. Yeah, that was 3-2, so we did round okay. All right, number 36. Find the missing variable, distance. We know that rate times time equals distance. Here we have rate is 75, stick it in. Time is 5, it's going to be our distance. So our distance equals 375. This was miles per hour, and we times by hours, so we get miles. 375 miles. Number 37. Tax. Now the tax was just the tax rate times the principal. So this is going to be 0.06, change percents into a decimal, and then times 29.95. Yeah, we're just taking 6% of 29.95. Let's punch that in the calculator. 0.06, not 0.6, 0.06 times 29.95, and we get 1.797, which would be 180 if it's just money, $1.80 if we go up to the counter and pay it. All right, 38, a discount. And we get the same thing we did here. Discount is just going to be a rate times the original price. So here we have 0.3. Notice that it's not 0.03. This is actually moving the decimal 2 places to 0.3 times 48. And that's going to equal 0.3 times 48, 14.4. So the discount is going to be $14.40. Put the units on there. All right, number 39, simple interest. Now this formula was interest equals P times R times T. And so really it's just like these up here, but now you're timesing it by how often that happens for so many years. So we get I equals, P is 2,500 times the rate, which is 3.5%, maybe we'll use a parentheses because we got a 0.035, times 2 years. Punch that into the calculator. 2,500 times 0.035 times 2, $175. And notice we know that we're in dollars because of that principle right up there. Okay, the temperature. We now have the temperature for this one is, let me see. We're trying to find C, so it's C equals 5/9 F minus 32. That's something you'd have to look up. Take the F as 88, put it right in there. We get C equals 5/9 88 minus 32. So let's punch that in the calculator. 5 divided by 9 times 88 minus 32. We probably could have done 88 minus 32 is 57 in our head, but it gives us 31.1 forever. 31.1 degrees Fahrenheit. Put that unit on there. Oh, degrees Celsius. Whoa, I just telling you to put the unit on is degrees Celsius. And we know that because we were solving for C. Okay, on the next one, however, you got to watch out just a little bit because the temperature, they switched it around. So we got to use the other one. We're trying to find F. And so that one is 9/5 C plus 32 with no parentheses on there. So when we stick a -12 in for the C, we get F equals 9/5 times a -12 plus 32. Stick that in the calculator. 9 divided by 5, no parentheses, times the negative 12. Notice I had to use the negative button, not the subtract button. Or you could have put parentheses around that right there. And then add 32 to it. And we get 10.4. So 10.4 degrees Fahrenheit. Excellent. The preparation problem, you're supposed to read 1.6 and we're going to codify and really articulate what happens with negatives. And yeah, we're going to learn that minus a minus, just like I'm not doing nothing, that's a double negative, makes a plus sign. So that's 2 plus 4 is 6. This one, because it's a subtraction problem, because they're opposite signs, so they're tugging in different directions. Negative 235 plus 17 is the same as 235 minus 17, but going in the opposite direction. And so we're going to get negative 218 because we started at negative 235 and then went up, or positive. So it's like 235 degrees below zero, and then it warmed up 17 degrees, so it subtracted down in that negative sign. You can see that here, negative 235 plus 17 and negative 218. And then C, here we have negative 23 plus a negative 61. These are both negative numbers, so this is actually an addition problem. 23 plus 61 is 84, but they're both in the negative direction. So it's a negative 84, and we only kind of did that to see that they were adding together. The values of them are adding together. And notice this, negative 23 plus negative 61. And yeah, it's a negative 84. It also would have been the same thing as 23 minus, with the subtraction button, 61. So whether you do plus the negative button or the subtract button, it is the exact same. Oop, I didn't write that right. Negative 23 minus 61, and you'll get negative 84 either way. All right.